Hi, my name is Dave and welcome to my Solidity Basic series. Here I will guide you through the fundamentals that you need to become a blockchain developer. At the end of this series, you will be able to understand how Solidity works and you will be ready to move on and learn more advanced topics to code smart contracts. So you can find all the videos on Skillshare and I left a link in the description. Please like and subscribe so more people can find those videos and start their blockchain development journey. Hi and welcome back. Today is the first actual lesson where we will start coding and writing something in the Remix IDE. So we'll go over variables and functions in Solidity. So Solidity, just as any other language, has many variables available. And today we're gonna explore the syntax, the different types, and I'll show you some pretty good examples. So let's go. Okay, let's start looking at some code. So once you open the Remix IDE, it's always going to show up with this example contract that we right now can just close. If we go look at the regular interface here, it's pretty straightforward, and we can just click here on New File. It gives you, like any other code editor, gives you workspaces available, and I have just created one for this course. But you can either use one of the sample environments or make your own. It's up to you. It doesn't really make any difference. Now, up here, we'll have a little button to create a new file, or we can create it from here. So new file, and we can start with a name. So in Solidity, it's a common procedure to name the file with a capital initial. So for example, we're gonna name this one here variables.sol. So every Solidity file is going to have the sol extension. And by the way, in the description of this course, you'll find a link to my GitHub repository where you will find all of the files that we're gonna write down here, just with many more comments. So comments usually are not comments are a very good practice, but you don't want to overdo them. And in these files that you find in the repository, they are way overdone, just because I want to have a way to have a static file without the video that explains many things. Okay, so once we save the file, it's going to be empty. And as we mentioned yesterday, every Solidity smart contract is always going to start with the same two lines, the license identifier and the Solidity directive. So the identifier is going to be written with the 2 forward slash in front. So the 2 forward slash in Solidity are the characters for comments. So when you want to comment something, you're always going to start it with the 2 forward slash. So here we'll do the 2 forward slash as PDX dash license identifier and as we mentioned yesterday, we're always gonna use in these lessons we're always gonna use the MIT licenses is the most open one. Then the Pragma Directive is going to come next, and that's, as we mentioned in the last lesson, the version. So here we'll use the keyword Pragma Solidity, and as you can see, the code editor actually gives you suggestions. So this is a very efficient way to code, and you can just press tab and it's going to complete it. Pragma Solidity, and we'll have the version. So in this case, we're just gonna use all the compilers from version 8. So we can use the character, the little top accent, and then 0.8.0, and end with a semicolon. Every instruction in Solidity ends with a semicolon, just like in JavaScript. And so this first instruction tells the compiler that all the version 8 should work. So we can write for example, if you want to code this, if you want to comment this to have a reference for later so you don't forget, you can do the 2 forward slash and then write whatever you want. Whatever you put in the comments is not going to be executed as code. So here, for example, we'll say tells the Solidity version. And so you'll have a reminder for later. What's next? It comes to the actual contract. So the instruction in the contract are encompassed in the contract keyword. So we'll do contract, and then after the keyword contract, it comes the name of the contract. And in Solidity is also a good practice to name the contract the same as the file. So in this case, we'll just name it capital V variables. And the two brackets here. So every time the instructions are inside the two brackets in the contract. Now let's start talking about variables. So just as in any other language, there are many variables available. The variables can be numbers, which in the programming world are commonly referred to as integers. There can be strings that are just a collection of characters like letters, names, but numbers can also be used as strings. They're just not going to be recognized as numbers, and so you're not going to be able to use those numbers to do mathematical operations. There are Boolean variables. A Boolean variable is just a true or false. So you can set up a variable to be true or false, and that can be used to maybe trigger another instruction later on. And Solidity has actually a few special variables that are a little bit more specific to the blockchain. So it has an address variable that only accepts the address numbers, and it has byte 32, which is just strings, but it's converted to bytes and is a little bit more efficient. We will talk more about later. Now let's start exploring the first the syntax. So how do we write a variable? We always write the variable type first, then the name, and then equal to a value. That can be a string, a number, or whatever the variable is about, and then the semicolon to end. Now in Solidity, if we only type the type and the name like this, it's going to be initialized directly to 0. So for example, if you want to have a integer variable that starts as 0 when the contract is launched or when the instructions are called, then we'll just put it out like that. Now let's go over the actual syntax. So if we want to make a variable for an integer, we're going to write something like int, and then the name number, let's call this variable number, equal 10. So in this case, we just created an integer variable named number, which is equal to 10. So one thing to explain about the equal sign here is, if you are not familiar with programming languages, the equal, it's not really unequal in this case. Unequal here is more like an association. We are associating the number 10 to the variable called number. Now, in Solidity, numbers have different sizes, and as you might know from general computer architecture, data in computers is moved in bits, and so when you have an integer like this, named just int, it means that this variable can accept numbers with a sign that can be minus or plus up to 256 bits. Why would you want to specify the size of the number? Well, because in crypto and blockchain, we work with very big numbers. You work with numbers that maybe have 18 decimals and things like that. So you want to make sure that the variable that you use accepts the right size. Now, if you know that you are going to work with a smaller number, you don't have to use the 256 bits. You can use a smaller one. You can create an int which is only 8 bits, and you would put the syntax at that int 8, you can have increments of 8, so you could have int 8, you could have int 16, and then you will name it another number equal to 1, for example. Now, one thing that I want to explain a little bit more is, you see how I wrote the name here, another, starting with a non-capital initial, and then the next word, it's with the capital letter. This is another convention in programming. It's called camel case typing, where you basically make separations between different words just from the initial. So you will see most of the variable name, you will see it typed in a way similar to this, where the first word is lowercase initial and then it goes to the uppercase initial. So this, for example, is an integer variable. Solidity can also have another integer type that is called an unsigned integer, and is usually the one that you will see the most in Solidity. And you write it, typing uint, and then the name. So unsigned number equal 50, for example. So this basically tells us that we can only use positive numbers. As in this one here, for example, int number, we could call it, we could associate it to -10 and it will work just fine. But with uint, you can only associate it with positive numbers, or rather unsigned numbers. Then next type that we mentioned earlier will be a Boolean. So Boolean starts with the bool, bool, 2O and 1O, keyword. And we can call this one a Boolean, that's name, equal to true. So when we are going to recall this variable, for example, in a function later on during the contract, the function knows that this value is true, and so we can use this to have the function do something. I don't know, if the variable Boolean is true, then write something. Next variable that we can look at is address. Addresses are very common in Solidity, as is the way to transfer currencies, right? And how to work with the contract. So same syntax, address, it's my address. And as we mentioned, this one only accepts addresses, and we're gonna put it between the double quotes. So let's say I want to use, in this case, I'm just gonna use the address that I have here in my MetaMask. I'll copy it, paste it here, and now this variable address called my address is associated to this Ethereum address right here. And then later on we will also see how to, for example, have the contract pick the address automatically when it's deployed and reused later, and things like this. The last variable that I want to mention right now is the bytes 32. So byte 32 is a type of variable, and we can just type some bytes equal a string that can be a name. And here we have a regular string. Actually, I forgot to mention the regular string. I'll talk about that after this. So here we have a string. As we mentioned, a string is just a collection of characters, right? The difference is that in this case, bytes 32 convert these strings in bytes, and just basically for the software is a little bit more efficient. And so it's usually a good practice, because every time that you code in Solidity, more code you have and heavier the numbers are and heavier the characters are, costs more gas to use to make the transaction. So if you can make it in a better efficient way, it's good, because then the customers or the contract will use less gas. And then this is going to be converted in bytes, and you will need to have a front end to convert it back into string. But anyway, the last one actually here, it's a string type. That is just a string, right? And we said a string is a collection of characters. So just this can be a word or a letter or anything with a character. So here are the main variables that you can have in Solidity. And just in a little bit after this, we will explore other variables available. Now, as you may see here, these variables here are all right in the contract. They're not inside the functions. So these variables here are called state variables. A state variable is a variable that is available to the entire contract. So we can, for example, call this function, call these variables from a function without having to maybe write it down again, or without having to specify it again, because it's already available to the entire contract. If we have variables that are inside a function, those are called local variables.